Have you ever wondered who discovered Jupiter, the largest planet in our solar system? Let's take a journey back in time, to when the first eyes turned skyward and discovered this celestial giant. It was not the work of a single person, nor even a single civilization, but a collective effort spanning centuries and cultures. The first records we have of Jupiter's observation date back to the ancient Babylonians. Their keen astronomers, thousands of years ago, were the first to document the movement of this bright object in the night sky. Fast forward to the 17th century, when the invention of the telescope revolutionized our understanding of the universe. Enter Galileo Galilei, the Italian polymath, who in 1610 turned his small telescope towards the heavens. What he saw not only confirmed that Jupiter was a planet, but also revealed something remarkable. Galileo discovered 4 points of light orbiting Jupiter. These weren't stars, but moons. The Galilean moons, as we now call them, Io, Europa, Ganymede, and Callisto, were the first objects found to be orbiting a planet other than Earth. This discovery was instrumental in shifting the prevailing thought of the time, from Earth being the center of the universe to the heliocentric model we know today. The discovery of Jupiter and its moons was a monumental leap forward in astronomy. It expanded our understanding of the cosmos, demonstrating that our planet was not alone in having moons, and that the solar system was far more complex than previously thought. So who discovered Jupiter? The answer is as vast as the planet itself. It was the collective work of ancient Babylonian astronomers who first noted its existence, and Galileo Galilei, who gave us our first detailed look at this giant planet and its major moons. So the credit for the discovery of Jupiter goes to both ancient Babylonian astronomers and Galileo Galilei. Now let's dive into the fascinating physical characteristics of Jupiter. First on our list is Jupiter's sheer size. Jupiter is the largest planet in our solar system, and it's not even a close contest. In fact, you could fit more than 1,000 Earths inside Jupiter. Its equatorial diameter is about 11 times that of Earth. That's like stacking 11 Earths side by side. Imagine that. But Jupiter's size isn't the only thing that sets it apart. It spins incredibly fast, taking just under 10 hours to complete a full rotation. This rapid rotation causes Jupiter to bulge at its equator, giving it a flattened shape. So, even though it's a sphere, it's not a perfect one. Now let's talk about what Jupiter is made of. If you were expecting rocky terrain like Earth or Mars, you'd be in for a surprise. Jupiter is primarily composed of hydrogen and helium, much like the Sun. This composition, along with its size, has led some to consider Jupiter a failed star. But don't be fooled. Jupiter may share some characteristics with stars, but it is definitely a planet. Another notable feature of Jupiter is its magnetic field. It's the strongest of any planet in the solar system, about 20 times stronger than Earth's. This magnetic field is responsible for some truly fascinating phenomena. It creates bright auroras at Jupiter's poles, similar to the northern and southern lights here on Earth. It also helps to create a harsh radiation environment around the planet, making it a challenging place for spacecraft to explore. Jupiter is a planet of extremes. It's the biggest, it spins the fastest, and it has the most powerful magnetic field. But these extremes aren't just interesting facts. They tell us a lot about how the planet formed and evolved, and they provide clues about the processes that shape our solar system. Indeed, Jupiter's physical characteristics make it a unique and intriguing planet. Ever thought about the weather on Jupiter? Well, it's wildly different from here on Earth. When you gaze upon the magnificent swirling visage of Jupiter, you're actually looking at the planet's thick and turbulent atmosphere. This isn't your typical weather forecast. On Jupiter, you can expect a constant storm, with winds reaching speeds of over 200 miles per hour. And these aren't just any storms, these are monstrous cyclones, some larger than Earth itself. Take the Great Red Spot, for instance. This mammoth storm has been raging on Jupiter for at least the past 300 years, and it's so large you could fit 2 Earths within it. It's a tempest of such grand scale and power that it makes our most formidable hurricanes look like a slight breeze. But it's not all about the storms. Jupiter's atmosphere tells a tale of vibrant, mesmerizing beauty. When you look at the planet, those colorful bands you see aren't just for show. They're actually different types of clouds made from ammonia, water, and other compounds. The lighter bands, known as zones, are areas of high pressure where the atmosphere is rising. The darker bands, called belts, are areas of low pressure where the atmosphere is falling. These bands are also colored by whatever is floating around in Jupiter's atmosphere. The shades of orange, brown, and red come from compounds called chromophores, which are created when ultraviolet light from the sun interacts with the molecules in the atmosphere. However, despite its beauty, Jupiter's atmosphere is not a place you'd want to visit. With a lack of a solid surface, extreme temperatures and pressures that could crush a spacecraft, it's a fascinating place to observe from a safe distance, but certainly not a vacation destination. So, the next time you look at Jupiter, remember that it's not just a pretty face in our solar system. Its turbulent, storm-ridden atmosphere is a testament to the dynamic and powerful forces at play. Jupiter's atmosphere is nothing short of a stormy, colorful spectacle. Now, imagine a planet with not one, not two, but 79 moons. Yes, we're talking about Jupiter, the giant of our solar system, a planet that has its own mini solar system of moons. Among these 79 celestial bodies, 4 stand out from the crowd. These are the Galilean moons: Io, Europa, Ganymede, and Callisto, named after the Italian astronomer Galileo Galilei, who discovered them in the early 17th century. Let's start with Io. It's the most volcanically active body in our solar system, constantly erupting and reshaping its surface. This fiery moon is closer to a vision of hell than a peaceful celestial body. Next up, we have Europa, the icy moon. It's believed to have a subsurface ocean twice the volume of all of Earth's oceans combined. This makes Europa a prime candidate in the search for extraterrestrial life. Imagine the possibilities that lie beneath its icy surface. Could there be life forms swimming in the depths of a moon so far away? The third Galilean moon, Ganymede, is the largest moon in our solar system. It's even bigger than the planet Mercury. Ganymede is the only moon known to have its own magnetic field, a truly unique feature among its peers. Lastly, we have Callisto, the most heavily cratered object in the solar system. Its ancient surface serves as a record of events from the early history of the solar system. Apart from these 4 major moons, Jupiter has a plethora of smaller moons. Each one of these moons, from the tiny shepherd moons that shape Jupiter's rings to the distant and irregularly shaped ones, has its own story to tell, its own secrets to reveal. The possibility of life, especially on Europa, has sparked immense interest and curiosity. The idea of life existing beyond Earth, in the cold and dark corners of our solar system, is a thrilling prospect. Jupiter's moons alone could be a topic of endless fascination. The mysteries they hold, the stories they tell, and the awe they inspire makes Jupiter and its moons a compelling subject of exploration and wonder. Jupiter, being the largest planet, plays a significant role in our solar system. Its sheer size has a profound impact on the celestial bodies around it. Jupiter's gravitational influence is immense, significantly shaping the orbits of many asteroids, comets, and even some planets. This gravitational pull acts like a cosmic shepherd, corralling these celestial bodies into specific paths and patterns. But Jupiter's influence isn't just about leading celestial bodies in a cosmic dance. It has another crucial role, akin to a cosmic vacuum cleaner. Its strong gravitational pull attracts comets and asteroids that could potentially threaten Earth and other inner planets. By drawing these celestial bodies towards itself, Jupiter acts as a protective shield, helping keep our planet safe from significant impacts. Now, let's talk about our exploration of this giant. Several missions have been launched to study Jupiter in detail. Pioneer was the first to fly by Jupiter in the early 70s, followed by Voyager, which gave us stunning images and vital data about the planet and its moons. The Galileo mission, named after the astronomer who first observed Jupiter's moons, was the first to orbit the planet and provided us with detailed insights into its composition and structure. Most recently, NASA's Juno mission has been sending back fascinating data about Jupiter's magnetic field, its polar auroras, and the swirling storms that dominate its atmosphere. These missions have not only increased our understanding of Jupiter, but also of the broader dynamics of our solar system. Yet, despite all these explorations, Jupiter continues to hold many secrets. It's a world of storms, with an intriguing array of moons, and its sheer size and presence have a profound influence on the celestial ballet of our solar system. Jupiter, the giant of the solar system, continues to hold many secrets waiting to be unraveled.